Okay, good afternoon. My name is Dr. Nagaraju, Assistant Professor in the Department of Computer Science and Engineering, Artificial Intelligence and Machine Learning, Institute of Aeronautical Engineering. Today, I am here to present one of the most important topics in the search techniques, which is called as best first search technique. So, if you want to understand what this best first search technique is, you need to have some basic knowledge about the search techniques. Before watching this video, you need to see the search techniques which are related to some heuristic functions. Means if you could able to easily understand the simple hill climbing approach, generate and test algorithm, and if you could able to understand steepest ascent hill climbing algorithm, then it will be very useful for you so that you can take the knowledge of that concepts and you can understand more clearly what this best first search technique is. So let us directly move into the concepts. As we discussed in the earlier session also, there are two different types of search techniques are available. As we know that most of the artificial intelligence kinds of problems, they are related to some search activity. Means any of the complex problem or any of the problem which is related to the real world, and if you want to solve such kind of problems by using artificial intelligence, then most of those problems, they are going to involve a very specific thing which is called as search. Means until and unless you apply this search process or you do this search process, you cannot able to get the answers for those questions. That's why we generally say that the traditional artificial intelligence programs or the problems are going to include, or they are going to be modeled as a search problem. So during this search problem, our task is only one thing, that is we need to reach to the goal state. Means we are going to perform the search activity starting from the initial state and primarily secondly, then we are going to move towards the goal state. So while traveling from initial state to goal state, every time we are going to make use of the transformation rules. Means whenever we apply these transformation rules to a particular state, it will allow us to move to the other state. Okay, so we can say that the search space, means if you talk about the solving of search problems, and if you talk about the search space, then definitely the search space is nothing but a graph or a tree. Means the entire search process we are going to represent in the form of a graph or in the form of a tree. And during this process also the same thing, what is our major intention is we need to reach to the goal state from the initial state. But we are doing some sort of improvisation. Why? Because in the previous search techniques also, means in the previous heuristic search techniques, we could able to identify, means we try to identify the path between the initial state and the goal state. But here, just identifying the path between the states is not a matter. So we need to identify the shortest path between the points. Means every search activity, we can say, if you are dealing with any search kind of problems, so the first activity what we have to do is we need to identify the path. Means we need to find out the path between the 2 points. Means between the initial point and the goal point, or between the initial state and the goal state. Once the path is done, next we need to identify the optimal path. Here what do you mean by the optimal path? Means it is nothing but the shortest path. It is nothing but the shortest path. Means if you could able to identify the shortest path between 2 points, then we can say that we could able to achieve the optimal results. Means in the search process also, some few algorithms during the search process, they are going to just concentrate on the identification of path, but they never concentrate on getting the optimal result. Means to get the shortest path. So if any of the algorithms which are not concentrating on these search on identification of the shortest path, then we can say that they are the uninformed algorithms, or uninformed search methods, or uninformed search techniques. And the other name for this uninformed is either it can be exhaustive, or simply we can say that blind search process. So here why we are saying it as a blind process means we are not going to take, means the AI agent, here we means the AI agent. The AI agent is not going to take any additional information from the problem statement in order to perform the search activity, or in order to traverse from the initial state to the goal state. So as he is not taking any help of the any information, as he is not concentrating any considering any additional information, so simply we say that it is a blind process. Means the example for this approach is the breadth first search. Means whatever the algorithms, best first search algorithm and depth first search algorithm they are following, they can be called as the uninformed search techniques only. Okay, so but the problem that that arises in uninformed is you cannot guarantee that you are going to reach to the goal state. In uninformed search techniques, without taking the consideration of the additional information from the problem statement, if you go on searching the path in between the points, so you cannot guarantee that you are going to reach to the goal state. And sometimes even if you get the goal state, you cannot guarantee that within the shorter period of time, within the shorter period of time, you are not going to reach to the goal state. Means if you look into those points, we can say that in uninformed search techniques, there is no possibility of getting the solution. That is a one problem. And the other problem is the time complexity is also very more. Okay. So for that one, what we have done is we are going to study the other type of search techniques, which is called as informed search techniques or heuristic search techniques. The difference here between this uninformed and informed is we are going to take the help of this additional information. So what this additional information is going to tell, it is going to give some support in order to identify the next step which I have to take, right? For example, if you see this is the initial state from where you are starting your search process. So think that there are two different paths where you can move towards the goal state. When it is a blind search, or we can say when it is in the informed search, what happens, you are going to select the next node blindly, means randomly you are going to select the next node. When you do it, we cannot guarantee that it may lead to the goal state. So that's why, because of that reason, we are saying that it is a blind search process. So in informed search, what happens whenever this kind of situation comes, means from the initial state, if there are multiple paths, if there are two successive nodes to this initial state, then which node you have to visit next. So that kind of information you are going to get when you are working with the informed search techniques. Means this informed search techniques, they are going to provide the additional information, means they are going to make use of this additional information and going to determine which node need to be visited next. Okay, so the example for this informed search is, it is called as best first search. So during this session, our concentration is on the best first search itself. So when you compare with the time complexity and when you compare with the performance, then we can say that this informed search techniques or informed search methods are so efficient when compared with the uninformed search techniques. Let us talk about the best first search. As I just mentioned that it is a kind of informed search technique. So in this informed search, we are going to concentrate first on the R graph. So what happens in this R graph, you see, the best first search, especially it is going to implement two kinds of algorithms, or we can say two kinds of search methods. One is the depth first search method and another one is best first search method. Because of this combination of implementation of these algorithms, we can easily say that best first search technique is so efficient when we compare with other search techniques. So what is the advantage that is taken by this best first search from DFS and BFS is, we can say this one. DFS is so good. Okay, DFS is so good. Why? Because it is going to allow us to find out a solution without searching for the other branches. Means what happens whenever there is a tree, this kind of thing, whenever you are going to see this kind of tree, so what happens generally, the best first search is going to take only one particular branch by ignoring the other branch. So what happens in this case, without observing the other nodes in the other branch, you could able to easily identify the solution. You could easily able to get the solution. So what happens in this case, you are going to reduce the time complexity. Means for a shorter period of time only, you could able to reach from the initial state to the goal state without considering the other branches present in the tree. Okay, so this is the behavior, or this is the thing what the best first search technique is going to observe. And when it comes to the breadth first search, so what is happening here, it is going to avoid It is going to avoid the dead end paths. So how it will be the dead end paths? For example, think that you have followed this particular path. So whenever your current state is in this point, and if this current state is not your goal state, so what happens? That means that you came to the dead end point. So in that case, what you have to do is you need to search in the other branch of the tree. But how can we do it? If you are implementing the depth first search, you cannot supposed to do these kind of things. If it is the best first search, what the best first search will do, simultaneously it is going to search both the branches that present in the tree. So whenever this dead end kind of things comes into picture, so if you could able to implement this best first search, then even you can search in the other branch of the tree also. Means, for example, if this is your goal state, if you are taking the help of this depth first search, what happens? You are moving to the dead end state. But this dead end state is not your goal state. So what the best first search is doing, it is taking the help of breadth first search. Okay, it is taking the help of breadth first search, and it is trying to observe in the other branch of the tree. So when it is happened, automatically we are going to move towards the goal state. Okay, one means the best first search is going to take the help of this depth first search and the breadth first search for these two reasons. One is to reduce the time complexity. Okay, to reduce the time complexity, we can say that the best first search can be implemented here, and in order to overcome these dead end paths. Okay, in order to overcome these dead end paths, we can make use of this best first search. So what is happening? By taking the advantage of these two methods or these two approaches, or by combining the behaviors of these two things which are really required for us. So what we are doing, we are making use of the BFS, which is called as here best first search. Means while implementing the best first search, you are going to see the behaviors of depth first search as well as the breadth first search. Okay, so in BFS and DFS, we are at a node. We can consider any of the adjacent as the next nodes. Means, for example, initially you have started from the initial point. So when you are implementing the best first search, if there are two successor nodes to this initial state, then you can consider either of these two. If it is a depth first search, you are going to consider either this one or this one. But here what is happening? We are implementing both depth first search and breadth first search combinedly and making the best first search approach. So in this case, whatever the adjacent nodes are available to this initial state, you can make use of it. You can select it. That means that our first duty is we need to explore the paths. We need to explore the paths without considering the cast function. Means when we are trying to identify the successor nodes to this initial state, we least bother about the cast. Why? Because we could able to identify, or we could able to generate all the nodes that present in this tree, search tree, we can say. Once it is there, next we are going to concentrate on the search cast function. Based upon the cast function, we are going to select either of these paths. Okay, so the main idea of this search process is we need to evaluate the function to decide which adjacent is most promising. Means initially what we have done, we have identified that there are two adjacent or two successor nodes to this initial state. Once we identify, next our duty is we need to select either this path or this path. So during the time of selection, we are going to consider this evaluation function. Means this evaluation function is going to give some cost which will be some numerical value. Okay, for example, think that here the numerical value is some 4 and the numerical value is 5. So which is the least cost function? Cost value 4. So in this thing we are going to ignore. Means this path we are going to ignore, and we are going to select this successor node. Okay, so here we can say that, means whenever we are talking about these values, then we can say that even the best first search is also going to make use of this heuristic search approach. That's why we can say that even the best first search is also some heuristic search kind of thing, or the informed search technique. Okay, so coming to the implementation point of view, when you are implementing this best first search, two things are required for us. What is the first? One is the heuristic search process. You need heuristic search approach, and along with that, you need two priority queues. You need to make use of two priority queues, or otherwise we can say two lists are required to perform this best first search technique. Okay, so for one priority queue we are considering it as open, the other priority queue we are considering it as close. Now what do you mean by this open priority queue, and why we are using this closed priority queue? So in the open priority queue we are going to keep the immediate nodes available for the traversal. Immediate nodes available to the traversal, and the closed priority queue we are going to keep the nodes which are already visited. The nodes which are already visited. For example, think that there are two nodes, node A, B, three nodes, okay, three nodes. So initially what happens, one priority queue, okay, for example, think that this is a priority queue, okay, this is a priority queue. In this priority queue, we are going to keep A initially. Okay, open queue, sorry, it is not a priority queue, it is a priority queue named open. Along with that, one more priority queue is also there, which is called as closed. Means at the initial state, there will be no label in the closed priority queue. So what happens when you complete the step number 1, this A is going to come to this place and B is going to come in this one. Okay, like that we are going to continue. Means we are during the implementation of best first search, we are going to make use of two priority queues. One priority queue is open, which we are using to place the immediate nodes which are available for traversal, and another priority queue which is called as closed, where we are going to place the labels of the nodes which we have already visited during our traversal. Okay, coming to the R graphs. If we talk about the R graphs, as we mentioned earlier, DFS is good because it is going to allow a solution to be found without all competing branches have been expanded. Means without considering the other branches also, with the help of this depth first search, easily you can identify the goal state, or easily you can reach to the goal state. And this one also, in the best first search, there is no concept of dead end points. Why? Because you could able to make the search of all the branches that are available in the tree. But now the question comes is how this depth first search and breadth first search we are going to implement in this one. Means based upon the cost values. Based upon the cost values, we are going to shift in between these approaches. Okay, means at the same time you are going to see two different kinds of implementations. One, a depth first search implementation, and another one is breadth first search implementation. Okay, so we will try to see that one, how to implement these two techniques in the best first search. Okay, so at each step of the best first search process, we select the most promising of the nodes we have generated so far. If this is done, our next duty is we need to apply some heuristic function. So heuristic function is going to support us. It is going to make us to decide which node need to be selected. Okay. So when we expand the chosen node by using the rules to generate its successor, then we can proceed our algorithm. If it is the one, means if the identified successor, means if the selected successor node is your goal state, then you can quit it. Means your search process is going to quit. Why? Because you have already reached to the goal state. Otherwise, you need to continue the process. Continuing the process is nothing but every time the new nodes, means whatever the new successor nodes you are identifying, all those nodes you need to generate. Okay, all those nodes you need to generate, and you have to keep it in the open node until and unless you get visited. Once those nodes are visited, then those nodes are going to be placed in the closed priority queue. So every time we are going to consider about the most promising node itself. If the newly generated node is the most promising node, then we are going to select it. Otherwise, we are not going to consider. Okay, in the depth first search, what is happening? The most promising branch is explored. Means first we are going to select a specific branch, then we are going to continue the search process in that branch itself. If the solution is not found, okay, if the solution is not found, then what we do? We are trying to start to look to the less promising state to the top level. Means we are going back. We can say some kind of backtracking we are implementing here. At that point, what happens? Previously ignored branch will be explored. Means, for example, this is a tree. So what we have done, we have selected this particular path to search for the goal state. But unfortunately, what we found that this is not the most promising node to us. So what we do, simply we will go back to this top level and we will take this particular path. Okay, so when this kind of approach is following, definitely we can guarantee that at any point we are going to reach to the goal state. So this example will make this the entire explanation very much clear. Means this example will shows how this depth first search and breadth first search simultaneously they are going to be implemented in the best first search technique. So this is your step 1, nothing but your initial state, or otherwise we can say it is a root node. Okay, if you are talking about a tree kind of thing. So next, in the second step, what we are doing, we are trying to generate the successor nodes of this A. So for example, those successor nodes are B, C and D. So what we have done, we have implemented some heuristic function. We have applied some heuristic function through which we got the values 3, 5 and 1. So from these values, we need to identify which one will be the node we have to consider to generate the successor nodes to it. Means, as we said, as it is very clear that D is having the less value. So what we are doing, we are simply ignoring. Means in step 2, after step 2, we are going to ignore these two paths. We are going to select only D. Why? Because its cost is very less. So what we have done in the third step, we try to explore the successor nodes of D. Then again, heuristics function we applied. So we got the values as 4 and 6. See, as we are not implementing the DFS only here, so every time we need to look for the applicability of DFS as well as the BFS, means breadth first search and depth first search. So in this case, what happens? You need to observe the cost of the leaf nodes here. So 3 for B, 5, 4 and 6. So in this one, which node is having the less value? So we can say that B is having the less value. So what we are doing when we are moving to the step number 4, we are going to ignore this. We are not going to consider these things, these paths. So we are trying to, means in step 4, we are trying to extract, or we are trying to explore the most successor nodes of B. So what happened? We could able to identify that G and H are the successor nodes. Again, we will apply the heuristic function and we will get some values. So what happened here? You see 6, 5, 5, 4 and 6. So when you compare all these values, again this 4 is the least value. So what we do here, we are going to ignore these paths. Means we are not going to consider this. Sorry. We will consider this one particular one. Means in the step 4, what we do, we will try to explore the successor nodes for E. Why? Because it is having the less cost. So what is happening here in this particular case, means in step number 2, we have implemented breadth first search. Why? Because we have explored the nodes which present in one level, all the nodes. But in step number 3, what we have done, by ignoring two nodes in the level, right, we considered only one particular node. So in this case, we can say that we have implemented depth first search. But again, in step number 4, what we have done, we move to this particular point, means we have implemented breadth first search. Okay, means simultaneously, means in the best first search, right, we are going to implement this depth first search and breadth first search at the same time until and unless we reach to the goal state. Coming to the algorithm implementation. So algorithm implementation, if it is a graph, we are going to consider two things. One is graph G and the other one is node. If you are talking about the tree, there is no need of this particular variable. So what we are doing, we are starting with the creation of one priority queue, which is called as open. So in the open priority queue, what you are going to keep? We are going to keep the initial state. Okay, so in the next step, means once the initial state is placed in the priority queue, open priority queue, then we need to identify the successors of the node. We need to generate the successors of that nodes. Once the successors are generated, and next what we have to do is, we need to generate before. So what we have to do, we need to apply or we need to evaluate it. For example, think that there are two things. One is A, B and C. So whenever you could able to identify this B and C, that means that you have successfully generated or you have generated the successor nodes of A. Once it is done, then the next duty is you need to perform the evaluation process. Okay, so in that evaluation process, what we are doing, we are trying to keep this node A. We are trying to keep this node A in the open priority queue. Okay, if it has generated before, means if that A is already generated, if the A is already generated, so what we are doing, we are changing the parent, thinking that this new path is the better than the previous one. So in this case, what we do, we are going to update the cast. We are going to update the cast to this node and to any successors that this node may already have. Okay, means every time cost is more important to perform the search activity here. Do the comparison, means when we do the comparison of this implementation of this best first search with the hill climbing approach, so we can say that this in hill climbing, one move is selected and all the other moves are rejected. Means ignoring the unnecessary moves and only considering the move which is making us to move towards the goal state, that we will do in the hill climbing approach. But in best first search, we are not going to ignore any of the moves. All the moves we are going to make use of it. Means for time being we will ignore it, but definitely we are going to make use of it in the coming steps. Let us try to see how this is the case. This is the example, right, which can makes you very much clear how this best first search technique is applicable or it is implemented. Okay, for example, see, this is a particular graph representation. So what is the task given to this in this is that we need to find out the shortest path between the initial node and the goal node. See, if you take any of the search technique implementation, its primary goal is to identify the shortest path only. So in this example, we are trying to identify, means our task is to identify the shortest path between the two nodes. So what are those two nodes? One is A and another one is G. So we can say that this A is the initial node. This A is the initial node and this G is the goal node. Otherwise, your initial state is this one. Means you have to start your search process from A and you need to reach to the goal state. After exploring all these paths, why? Because there are multiple paths available to reach to the goal state. So your first primary duty is you need to explore all the paths by implementing DFS and BFS at the same time. Once all the paths are explored, your next duty is you need to identify which one is the shortest one. Okay, so our task is to identify the shortest path between the initial state and the goal state. So what we require to implement this algorithm? We require the heuristic values. Heuristic values are more important to decide which node to be our next node. Okay, for example, you see from A we are having three different paths. Means we can say that A is having three successors. Okay, one is B, C and another one is D. So in this case, which node I have to select? Means what will be my next node after A? So during this case, right, the heuristic values are going to help us to select either B, either C or D. Means the requirement for us is the heuristic values and we require two priority queues. One priority queue is open and another priority queue is closed. So the consideration, so what we are going to consider? We are going to consider some heuristic values as distance. Distance is nothing but some Euclidean distance. Okay, Euclidean distance means it is not the distance between A and B. Euclidean distance is nothing but distance from every node to the goal node. Every node to the goal node means it may be the distance from A to G or it may be distance from B to G, C to G, D to G, like that. Okay, so that is called as here the heuristic distance. Okay, so these are the considerations. So we need to consider the Euclidean distance between the nodes to the goal node. This is the first step. So this is the graph given to us. So in this graph, our first duty is we need to explore. Why? Because we are starting our search process from this particular point. Okay, this is our initial state. So in step number 1, what we have to do is we need to identify the successor nodes of this one. So what are the successor nodes here? It is very clear that B, C and D are the successor nodes. Why? Because there is a path in between these three. There is a path. So what is happening? Once these successor nodes are done, initially what we are doing, we are keeping this A in the open queue. The closed queue will be remains empty. Why? Because we have not visited any of the nodes so far. Okay, so after completing the exploring of these successor nodes, the graph will looks like this. It is a partial graph. So what is 53, 40 and 42 are telling that? They are the heuristic values. They are the heuristic values. Otherwise, you can consider these are the Euclidean distance. Means the distance from B to G is 53, from C to G is 40, and from D to G is 42. Okay, so once this exploration of these nodes is done, so what we are doing, that means that we have visited B, C and D. Sorry, we have generated B, C and D as a successor nodes. So you keep those nodes in the open priority queue based upon the priority values, means based upon the Euclidean distance. So C is having the less Euclidean distance, so we are keeping this C 40 in the front box, and then D 42 and B 53. So what happens, what we are doing, from the open priority queue, we are bringing this A and we are keeping it in closed priority queue. That means that A is the node which we have already visited. Means you should understand that closed priority queue is going to have the names of the nodes which you have already visited. Okay, so this is your first step. Once step number 1 is done, then in the second step, again we are going to select C as our next point. How it will be? In this case, if you observe, the value means the Euclidean distance from C is very less. That's why simply we are ignoring B and we are ignoring D. But remember, we are not going to delete these nodes information. They are going to be kept in the open priority queue like that only. Okay, so as based on the values here, we are going to consider C. Means our next exploration will be this one. Means our state is here. So now in the step number 2, what we have to do, we need to generate the successor nodes of C. So from the graph, it is very clear that the successor nodes for C is either, as it is having two different paths, which are one is pointing towards D and another one is pointing towards F. Then we can say that the successor nodes for this C node is F and D. So what about the Euclidean distance? The Euclidean distance from F to G is 44 and from D to G is 42. So in the second step, what we have done, you see, we have kept this C and D in the closed priority queue. Why? Because these are the nodes we have already visited. So what we are doing here, we are simply ignoring this F, but we are keeping this in the open priority queue. This B value is already there from our step number 1. Okay, so once it is done, again what we are doing, we are going to consider D. Okay, so how it happened, you see, from A, we have started the search process. Based upon the Euclidean distances, we could able to reach towards C. From the C, as there are two other points, by the help of that Euclidean distance, again we selected D. Why? Because D is having less Euclidean distance value. So what is the next step? So our next step is, you need to generate the successor nodes for D. Why? Because D is having less Euclidean distance. So if it is a case, so what happens, from D, again two things are there. One is G and another one is C. Because 2 is also having, right? So in this, what we are doing, we are going to calculate the Euclidean distance, right? So that Euclidean distance from D to G means whenever you reach to the G, so the Euclidean distance will be G. That means that the distance from G to G, obviously it will be 0. Okay, and the distance from D to C, right? It is not the distance, sorry. The Euclidean distance from C to G is 40. But we know that already C we have visited. when C is visited, it's not necessary to consider this one. We are going to consider only this. So what happens in that case? The Euclidean distance from G to G is 0. So we are going to keep this one in the closed priority queue. Okay, that means that initially we started from A by taking the consideration of Euclidean distance, minimum Euclidean distance value. From A to C we went, from C to D we went, and from D to G we went. Means this will be the shortest distance between A and G. So we can say that ultimately we can say that this is the shortest path. Means starting from A to C, then moving from C to D, and again from D to G. This will be the shortest distance. Okay, like this, the breadth first search technique is going to be implemented in order to identify the shortest path between two different nodes. Okay, so these are the references which I have used to prepare this content. Okay, we will come up with another topic in the next session. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.